In our last oil and gas safety video, we examined what caused one of the biggest refinery explosions in the US and how to stop similar incidents from happening. Today, we're shifting focus to another recurring safety challenge in the oil and gas sector: electrical hazards. Over 3,700 non-fatal electrical injuries are reported annually, leading to hundreds of millions in direct losses. That's why in this video, we'll unpack the most commonly misjudged risks, examine real-world accident scenarios, and walk through field-tested strategies that frontline teams are already using to reduce exposure and prevent costly failures. Oil and gas facilities are pressure cookers of electrical potential. Wet zones, flammable vapors, and thousands of amps coursing through high-demand systems. One oversight can cost a life, halt operations, or trigger a lawsuit. And the worst part? Most hazards don't look like hazards until they explode. To fix the problem, we need to understand it. Let's start with three of the most overlooked hazards in the oil and gas industry. Static discharge during tanker loading happens when flammable liquids like oil or gas are transferred into tankers. The friction from the liquid's movement generates static electricity. If this static charge builds up and discharges as a spark, it can ignite flammable vapors, potentially causing an explosion. Junction boxes contain electrical connections from various parts of a system, such as pumps, sensors, and control equipment. Typically constructed of metal, they shield connections from environmental hazards. However, the harsh conditions of oil and gas environments expose these boxes to moisture, salt, and corrosive chemicals, leading to corrosion. This corrosion weakens connections, significantly increasing the risk of short circuits, equipment failures, and fires. Zoning classifies areas based on the likelihood of flammable gases or vapors being present. Each zone requires specific electrical equipment to prevent ignition. Improper zoning happens when areas are misclassified, leading to the use of unsafe equipment. How to stay ahead of these electrical hazards? It comes down to prevention, but not the kind that sits in a binder collecting dust. I'm talking about practices that are lived out every day, on the ground. The danger isn't always visible during tanker loading, and since it's a routine task, workers may become complacent about the risk. Grounding the tanker and using bonding techniques, such as connecting the tanker to the loading equipment with a conductive cable, dissipates static electricity safely. Regularly checking grounding systems and following strict loading procedures are also essential. Regular inspections and maintenance are critical in the oil and gas industry. Corrosion develops gradually and may not cause immediate problems, so it's often ignored during routine checks. Using corrosion-resistant materials, sealing boxes to keep out moisture, and applying protective coatings can help. Using thermal imaging to monitor environmental factors like humidity or chemical exposure also reduces risk. A visual inspection might miss a loose connection inside a panel, but an infrared scan will show a hotspot before it fails. Errors in zoning typically arise from inadequate training, human negligence, or failing to update assessments following operational modifications. To effectively prevent zoning inaccuracies, conduct comprehensive risk evaluations and routinely revisit zoning classifications, especially after any operational changes. Equip personnel with thorough training on zoning standards, such as ATEX and IECEX, to ensure compliance and safety. And of course, PPE layering. It's not just about throwing on gloves and a hard hat. Workers need arc-rated clothing, insulated gloves, and face shields. I've seen guys wearing the right gear but not actually rated for the job they're doing. And when that happens, it's like the protection has already failed before they even get started. Consider this real-world incident. In September 2019, at an oil and gas site in the Gulf Coast, a support crew member was removing a bypass from an electric meter box. It wasn't a lead electrician, but still trained personnel performing a common task. Suddenly, an arc flash erupted inside the box. The worker sustained significant burns and was hospitalized. Thankfully, they survived. So what went wrong? The meter box wasn't properly de-energized, no established lockout-tagout process was visible, and no inspections had been done before the bypass removal. In short, they were performing routine tasks without proper protocol. Rather than passive, preventative measures must be proactive, intentional, and field-proven. A zero-incident culture doesn't exclusively happen through posters or penalties. It begins when safety becomes part of the workplace culture. This mindset shows up in simple but powerful ways: daily walkdowns, tech-driven alerts, and empowering anyone, including interns and temporary workers, to call out unsafe conditions. The results speak for themselves. Since their widespread adoption, NFPA standards have helped reduce workplace electrocutions from 582 to 164 cases over the past 4 decades. But meaningful implementation goes far beyond ticking boxes on a checklist. It demands consistent leadership commitment to safety over production pressure. Leading operators are setting the tone with risk-based maintenance schedules that prioritize hazard mitigation over cost-cutting, even during downturns. Training is evolving too. More teams are using virtual reality simulations to immerse workers in hazardous scenarios without real-world exposure, a deliberate practice that builds instinct. Ultimately, this transformation is not about meeting compliance, it's about redefining what being safe means. Because at the end of the day, safety isn't measured by the incidents we prevent, it's measured by the lives we protect. If you found this video insightful, be sure to like and share this video. Subscribe now and never miss an update that could save lives.